Hi everyone, we're going to do one more example sketching the graph of a rational function. Let's begin by identifying the asymptotes. This graph will not have any vertical asymptotes because the denominator of this function is never 0. It's x squared plus 1, something that's always positive or 0 and then plus 1, so it's never 0. And therefore no vertical asymptotes. Now this graph will have a horizontal asymptote. I can see the degree of the numerator is the same as the degree of the denominator. So the horizontal asymptote will be the line y equals, then I take the leading coefficient from the numerator, it's 2, and put it over the leading coefficient of the denominator is 1. So it's 2 over 1. In other words, the horizontal asymptote is the line y equals 2. Here it is. And before we talk about the oblique asymptote, let's check if the graph is going to cross the horizontal asymptote. For that, I'm going to take 2 and plug that into the function for y. In other words, I will replace f of x with 2. Here's the equation that I need to solve. That's where I placed 2. If this equation doesn't have any solutions, it means that the graph will not cross the horizontal asymptote. And if this equation does have solutions, that will indicate that the graph crosses the asymptote. Let's see. To solve this equation, I'm going to multiply both sides by the denominator in order to clear it. In the next step, I'll get 2x squared plus 2 equals 2x squared minus 5x minus 3. If I try to combine terms with x squared on one side, then I can see how all terms with x squared cancel. This leaves me with 2 equals negative 5x minus 3. From there, I'll get 5 equals negative 5x. And once I divide by negative 5 on each side, I'll get negative 1 equals x. Okay, so it looks like we're able to find a solution to this equation. And that means that the graph will cross the horizontal asymptote at x equals 1. So basically the point of intersection has coordinates negative 1, 2. And I can already plot this point. Negative 1, 2 is right here. If you're a little confused by the fact that the graph crosses the asymptote, even though we said that graph never touches or crosses the asymptote, keep in mind that when we say that, we refer to the end behavior of the graph. So basically, our graph will cross this horizontal asymptote at this point, negative 1, 2. However, its end behavior will be such that the ends of the graph will approach this horizontal asymptote on the right and on the left without crossing or touching it. Now, what can we say about the oblique asymptote? Well, it looks like the graph will not have an oblique asymptote because the degree of the numerator is not 1 more than the degree of the denominator. Next, let's find the y-intercept by letting x be equal 0. In other words, by finding f of 0. When I plug in 0 into the function, every terms involving x will turn into 0, so I will be just left with negative 3 in the numerator and 1 in the denominator. So it's negative 3. The y-intercept is the point 0, negative 3. I plotted it here. To find the x-intercepts, we'll let y be equal 0. In other words, we need to solve this equation. After multiplying both sides by the denominator, and this way clearing the denominator, I am left with this quadratic equation. I'm going to use the quadratic formula to solve it. And this equation produces two solutions, 3 and negative 1/2. This means that the graph is going to have two x-intercepts, negative 1/2, 0, and 3, 0. I plotted them here. Now this is what I have after performing the first 3 steps. Horizontal asymptote, I know the ends of the graph will approach it, and 4 points, with one of them being right on the asymptote. I know that I will need to find a few more points to better understand how the graph will be positioned, but since I know that it's going to cross the horizontal asymptote, it means that portion of the graph will be below the asymptote, and that means that it will have to approach it from below. So most likely it's going to go here to the right and approach it from below. And at this point, the graph will cross the asymptote and it will appear above the asymptote. So it will have to continue and then approach the asymptote from the above. I want to make sure that I don't cross this asymptote at any other points besides the one that we found. To better understand how a graph behaves below the asymptote, I'm going to find points at x equals 0.5, 1, 2, and 5. Okay, so these are the 4 additional points. Here they are on the graph, and now I can better see how the graph curves and bends and then starts approaching the horizontal asymptote from the below. Here's this portion of the graph. And to check what happens above the asymptote, I'm going to find points at -2, -2.5, -3, and maybe -5. So these are the 4 additional values. And these are the corresponding points. So it looks like the curve is going to rise and then turn approaching the horizontal asymptote. Like that. Very interesting graph. By the way, we just performed step 5, sketch the graph.